Okay. You might be getting bored by now, so this is going to be kind of a long one. We're going to start with benzene and ethanol. These are your only sources of carbon. So every carbon in the product has to come from these two molecules. Okay? So this is the product that you have to make. That looks tough. Okay, so what I want you to do is go ahead and hit pause. Seriously, there's no point in just watching this, all right? If you just watch this, you're not going to learn anything. Hit pause and then work out a synthesis where any number of reactions that you want that you make this compound. Pay attention to regiochemistry and numbers of carbon. Okay, so now that you're back, I'm gonna just talk about some stuff over here on the right before moving over and doing the whole synthesis. So, some things that you should have noticed in your synthesis here. Right, obviously the benzene rings are gonna come from the benzene. You're gonna rely on the chemistry you learned. What chapter was that? Chapter 18, electrophilic aromatic substitution, nucleophilic aromatic substitution. Ethanol, we're going to talk about. You can see over there on the right now, where you're going to have to adjust the oxidation state of the ethanol. So ethanol starts out with one bond to a heteroatom. You guys know how if this is dry. So if you use dry PCC or Des Martin or the Sworn oxidation, any of those that we did in chapter 19, you can take that alcohol to the aldehyde. You can also use any of the oxidations we've done wet, so any chromium-6 oxidation, wet, Des Martin wet, and you can get the carboxylic acid. Okay, the other two things to look at. The first thing over here on the left, all right, what about your non-benzene carbon? How does that look? Well, there's two non-benzene carbons, and then you've got two up here. Okay, so ethanol, conveniently enough, has two carbons, right? So there's ethanol. So it's a good bet in this synthesis that these two carbons came from ethanol. Look, there's even an oxygen on one. And these two carbons come from ethanol, and there's an oxygen on one. Okay, so what does that mean for the bonds that you need to break? Need to make? Right, you need to make this carbon-bromide bond. You need to make that carbon-carbon bond. You need to make that carbon-carbon bond. So you're going to have to add phenols in there twice. You're going to have to do a reaction that makes a bond to a benzene twice. And then you're going to have to make that bond. And these. But again, the ones up here can be adjusted from the oxidation of ethanol. This one's a little tougher. And the other thing, and I've indicated that over here, okay, you're in the final product, this bromine is meta to something. And if you come back over here and you look at this, that carbon as an alkane, it's got an oxygen on it, so it's a little bit electron withdrawing, but it's also, you might think that's an ortho-pair director. The bromine's certainly an ortho-pair director. So basically what I'm trying to get at some point X here had to be a meta-director and the bromine had to go on after. So we're only going to put that bromine on after. Okay, so one more time and you can go back and watch it. The relationship on the left-hand ring over there in the product, the relationship between the bromine and the rest of the molecule is meta. Bromine's an ortho-pair director. That means that this X, whatever the rest of the molecule is, had to at some point be a meta-director, and it had to go on first before the bromine went on. Okay, so, and as you look at that, you can start to kind of see that. So again, if you got stuck on the synthesis and you just hit play, just go, like with those hints, hit pause again. If you don't, or actually do that anyway, even if you think you got it, hit pause, go back and look at your synthesis, and then come back. I'm actually going to have to pick this up now and go over here Hope that didn't make you seasick. Okay, so you should have that written there, what the product is. I'm gonna write the product one more time here in green. Kind of giving stuff away there. No, now I'm just telling you what it is. Methyl. So here's our target. Okay, so you have, while I was drawing there, you probably saw the reaction written in black up there. Again, that's how we install a bromine into a benzene ring. Just an electrophilic aromatic substitution, so Br plus for H plus, bromine, iron tribromide, gives us bromobenzene. And then what's the reagent you need to turn that bromine into a Grignard? And the reagent is just magnesium. Magnesium 0 there, gets you that Grignard. Okay, so you've got everything you need on the board now. We've got acetyl chloride, we've got acetic acid, ethanol, bromobenzene, phenyl magnesium bromide. We can actually do everything we need to do with the reagents on the board. So again, if you need to stop, if you're like, oh crap, I really screwed something up, go ahead and hit pause and see how you could make this, the target molecule, this target in green, from the stuff written on the board. And I guess, so now that you're back, I guess I should say, you might have found a different answer to this. You can email it to me, you can ask, if you're in my class, you can do that. If you make the comment on YouTube, I'll try to get to it, but I don't often see those, so I don't always see those. Okay, so let's start. Let's start with, we've sort of done the retro analysis, let's go forward. So we're gonna take benzene, and the first thing we're gonna do is put some chlorides on. So a Friedel-Crafts acylation, acetyl chloride, which we got by oxidizing ethanol up to acetic acid, and then treating with thionyl chloride gets us acetyl chloride. Treat benzene and acetyl chloride with aluminum trichloride, and we will get acetophenone. Now we have a ketone. And now at this point, you could go do a whole bunch of the stuff you do with the ketone. I think you can see this, right? You've got, so the methyl on the ketone is that methyl. The carbonyl carbon on the ketone is that carbon. And so maybe you have this flash of insight, right? Like if I reduce the carbonyl carbon to an alcohol, I can put the acetyl group on. But then that leaves you with nothing to do here to put this phenyl group on. So the next thing you need to do, well, first of all, the next thing you need to do, here is a bromide. You got to get the bromide on. This acetyl group is now a meta director, so it's in a perfect position to do this. If we brominate acetophenone, we'll get our meta orientation. Let's make sure I'm still on the screen. Okay, good. All right, now that's sort of the first thing. Now we take that's our first set. Now we take the phenyl magnesium bromide that we made up at the top. And you actually have to be a little careful here. It's possible to do metal halogen exchange. So basically, you can swap out the phenyl for the acetophenone. And I got to admit, when I drew this up, I wasn't thinking that far ahead. I don't think that's a problem. I think you can do this reaction pretty well. So this gets us an alcohol, that methyl, and then the bromide's here. Doesn't really matter how you draw this. You can put this ring over here and that ring over there. You could draw the methyl up and both rings down. It doesn't matter. That is a chiral center. Again, stereochemistry. That's a chiral center now. You got an alcohol, a methyl, a phenyl, and a bromophenyl. 4 different things. But you're adding a nucleophile to a trigonal planar achiral ketone, you're going to get a racemic mixture. So you'd have to do some sort of resolution or chromatography. And you're really close now. So you've got an alcohol, and you need to make an ester. Okay, so this is chapter 20. If we run through Klein's chapters, chapter 18, 18, 18, sort of 12 and 19, 12 and 19, 12 and 20, 12 and 19. The synthesis is in chapter 11. Okay, so we just need to make this ester bond, and there's a couple of different ways to do that. You might, in class, I've talked about the Fischer esterification a lot, where we would take acetic acid and this alcohol, and we'd reflux them with some acid present. And what that will do, almost certainly, is an elimination here. So if we took, so this is sort of going the wrong way, catalytic H plus and acetic acid, and we reflux this, you might get a Fischer esterification between this carboxylic acid and the oxygen, but it'd be really low yield. What you would do is you'd protonate here and then do an E1 elimination. And so the product would be that. And now that's a conjugated double bond, so this might work because you could protonate it, you could protonate the alkene and treat it with acetic acid, and you'd go to, you might get the product you want eventually, but it'd be low yield, and this elimination product would be a really big problem. Much better would be to do acetyl chloride, triethylamine, and this will get us our desired product. Bingo bango. That actually is our desired product. You guys might, sitting at home, you might be irritated that I've drawn the acetate pointed the other way. It doesn't matter, that works just fine. Okay, I think that's it. If you have any questions, let me know.